All right, it's a new day. We're evaluating and we're checking out a new pattern called greedy techniques. Look at the pattern, its real world applications, and problems we can solve with it. Starts off with a definition of an algorithm, a series of steps used to solve a problem. Right? And there are different types of problem solving algorithms, and greedy algorithms are one of them. So it's a paradigm, like greedy algorithms, or considering an algorithm as greedy, says that it builds up a solution piece by piece. It chooses the next piece that offers the most obvious and immediate benefits, the most obvious and immediate benefit. And as the name implies, it always makes the choice that seems to be the best at the time. It seems to be the best at the time. So it's a locally optimal choice in the hope that that locally optimal decision will lead to a globally optimal decision. And they are used to solve optimization problems. They work by recursively constructing a solution from the smallest possible constituent parts. And its defined recursion, which we've seen, especially in the last few videos, is an approach to problem solving where the solution to a particular problem depends on solution to smaller or equal instances of the same problem. And they have a downside of getting stuck in local optima and generally do not return the global best solution. But they're still useful, apparently. So networking is in particular for networking, where the approach solve problems such as the traveling salesman problem is like a classic. Prim's minimum spanning tree. All right. I think this explains it. It explains how it doesn't guarantee an optimal solution. So let's take it from the top. So we have this diagram and we want to find the path with the maximum sum of node values. So the path you take from up top to the leaves, from the root to the leaves, that has the maximum sum of node values. Now a greedy algorithm will look for nodes with the largest values. And so it's just say, okay, from 6, 13 is bigger, so let's go there. And then from there, 11 is bigger than 1, so let's go there. However, this is wrong. This is not the path with the maximum sum because there's this 6, 8, 80 down here, right? I was missed just because 8 is less than 13. So that I think that explains what they mean by it's not always the global optimal solution. And he gives some examples of problems you can solve with this approach, with this greedy approach. Honestly, I feel like we want to go through this in particular, like as an actual problem instead of just this diagram because it doesn't really say much. If I'm being honest, same with this one. Color a graph that no two adjacent vertices are colored using the same color and minimum colors are used. In my opinion, yeah, these don't say much about this pattern introduction. So let's just get into solving problems as quickly as we can. But not in this video though, in the next one. So how do you know it matches this pattern? Your problem matches this pattern. If a series of local optima allows us to construct or identify the globally optimum solution, and know if any of these, it doesn't apply if any of these conditions are fulfilled. So if local greedy choices lead us to a suboptimal solution, nada. If there's no local optima, nada. If it's not an optimization problem, no bueno. And then here are some real world problems that use greedy techniques. So CPU scheduling, so many algorithms which use the greedy approach help in CPU scheduling. And LAN networks, in a large local area network with many switches, finding a minimum spanning tree is important to ensure that only a minimum number of packets will be transmitted across the network. Social networking sites, they recommend a list of people that the user may know through Dijkstra's algorithm, and it finds the shortest path between users measured through connections among them. Okay. Oh, strategy time. So we're going to be matching problems that are greedy. Shortest period of time to schedule a set of jobs on a machine. I'm gonna just try this. I could be wrong though. Palindromic substrings containing a different string. Some of the pattern. Shortest path between two intersections. Cost-effective way to lay optical fiber. Because why not? Let's try it out. Ooh, we got it. Nice. Some bunch of explanations. Okay. I'd say that's all for this introduction video. I'll see you in the next one. Ciao.